So before we start coding circuits, we want to learn about how circuits are made. And who's better to take that information from than our very own Mike, who is our production manager here at GHI Electronics. Hello, Mike.
Hello, Gus.
Okay, Mike, so before we get started, can you tell us quickly, what is a circuit board assembly?
It is a process of taking components in a raw board and putting those together to get the final product.
A circuit is a bare circuit. That's what you're telling me, that's manufactured separately?
Correct.
The components are manufactured also separately, and these are made by different companies.
Correct.
Where you come in is taking these parts and placing them on that circuit.
Correct.
What got you into circuit board assembly? How did you start?
From basically being young, I've always liked to take things apart and put things back together, and it always intrigued me about how things work in special electronics. I went to ITT Tech right after high school, started off as a tech doing repairs of circuits, and then eventually went to the process of manufacturing circuits.
Did you do any soldering at home before you did it professionally at home? Did you
Actually, no, I really didn't do any soldering at home.
That's interesting. But now you do soldering all day, every day.
Yes. Yes.
And so at school, it was you learned about electronics, or you learned about circuit board assembly?
For there, it was like learning about just electronics, what a resistor is, what a capacitor is, building a circuit, Ohm's laws and all that to make a circuit. And we even did a robotics project too.
And then when did you start professionally building circuits? When was this your first job, and now you're actually building circuits for a living?
Probably back in 1994.
Oh, wow. Long time.
Yes.
Okay. A lot of experience. How did you learn about GHI Electronics?
A sales lady brought in GHI components where I worked at to build their circuits at the time. They were outsourcing it. And then eventually Gus came to me and saying, hey, if I'm spending X amount a year for outside source, what does it take to get new machines? I said, hire me in, and then we go from there.
So that was our leap into getting into manufacturing.
Yes.
So actually we started at GHI Electronics building circuit boards together with Mike, because he was the initiator of that new venture. It was fun times.
Yeah.
It was fun times. One of the things I love talking about is having a jet printer versus having a stencil printer. Can you tell us more about what is a stencil printer? What is a jet printer? What is that used in the assembly process? And why we chose to have jet printers?
So stencil printer is pretty much what it says. You have a stencil that has holes in it, and then you drag a blade over that pushes the solder through onto the board.
Through to what? Onto the board.
Onto the board.
So we have a circuit, stencil on top.
Yep.
And
board
then
underneath.
The board underneath, and then solder.
Squeegee goes across. Yeah, there's a solder across on top of the stencil. Then the squeegee goes across, and it forces it through the holes onto the board. And then the board drops down and goes to the next stage. Where jet printer is like an inkjet printer where it's spitting out the paste, and it's like a bombardier where it shoots it from point A to point B, and it just lands where it's at. It's very accurate.
What does that give you? Why do you need a jet printer versus a stencil?
If you need to make a board change, you don't need to get a new stencil for that. You just change the software. It's all software driven.
It's just like a printer. You go to a computer and you print. There's no stencil needed.
Correct.
Now, doing this for such a long time, we're talking about 30 plus years, I'm sure you've gone through simple, complex, small, large, all kind of circuits. Anything that's you always remember that one complex or one really simple or one really large circuit that just you remember that for some reason?
Building radios was very complex. They just like to use every value that's out there.
They're very particular, right, in radios. When in digital circuits we use 10K or 20K ohm pull-up resistor, it wouldn't make a difference. But when you're building a radio, I guess that makes sense. You have to have 10.1K at 0.1% tolerance, something crazy. So what was the most complex circuit like?
Yeah, there was so many different parts that there was just not enough room in the machine. We had to run it through the machine 2 times for each side.
So that the board has to go through the machine 4 times?
Correct.
That's interesting. So the machines have there's like a few bays, if you will. Like there are slots where you would add the individual components on the pick and place machine, we're talking about the previous step earlier. That's the solder, where the solder is placed on the circuit. That could be a squeegee or jet printer like we have here. The next phase is the pick and place machine. And what Mike is talking about is all these slots where you add the individual reels and the machine pick up the individual parts and places them. So let's say you have 100 slots. You can put 100 different values. So I have 10K, 1K, and then I have resistors, capacitors, transistors. And when these slots are full, you have no choice but to have a second machine in line. So one machine places like half, the second machine in line places the remaining parts. Or you would run the board and then you bring the board around, feed the machine with the other set of parts and place those parts again, which sounds crazy, but for a smaller run, I guess that would work. Now, can a machine place parts on top and bottom side at the same time?
No, it's a two separate process because parts will just, if you don't have them soldered, it'll just fall off.
So then how do you do it? Like you put parts on one side. When you flip it, how do parts stay on the board? They don't fall out.
By the reflow process. So once the reflow process happens, they are melted to the board.
That's the third phase of the build process. So solder, pick and place, parts getting placed on the surface. That's why it's called surface mount. And then it goes through an oven, a really nice pizza oven. That's what I always say, with too many configurations. That's a reflow. And then from there, the parts are glued, soldered on the circuit. How small can components be, or how large can they be? What have you seen in the past, or what have you placed in the past?
So far I've seen that there's 01, 005. I have not placed that. The smallest that we have placed has been 0201s.
And those are extremely small.
They're like smaller than even a pepper flake.
Yeah, so those are the smallest. But then let's go to the other extreme. Like, have you placed like large components, and what are these used for?
Usually a lot of those large components would be like BGAs, and then we even have ones where for a through-hole part, but like a big power supply that gets soldered to the board.
So I guess that's a whole module, right? Like there's an entire power supply inside, but then that's also comes to you as an entire assembly, and you place that.
Correct.
How do we assure quality when you're building circuits?
We will verify the placement of the components through the camera of the machine itself first before you actually even place a part on there. So we can make sure that it's oriented right, and then we double check that the pickup is correct. And then we'll actually build it, look at it, put it through the oven, test it, and make sure everything's good.
And this is where having the engineers and the production under one roof sets us apart from a lot of companies out there. We are GHI Electronics, we do the hardware and the software, and we do the manufacturing. Literally, an engineer can walk 20, 30 feet to the plant and grab a circuit from Mike and test it out, verify everything's good. Or if Mike is having any questions or concern, he can easily reach one of the engineers and say, come out here, this is the tester, something's not failing, what's going on? Doing this for such a long time, you're an engineer at this point. You understand components, circuits, like you have even sometimes pointed out things that engineers made a mistake on, and you caught it on your end.
Information is actually key, especially for stuff like that. Complete part numbers, making sure that we're getting the right part for the right size. Did they lay out for the right size? And I've actually caught where it's been two different, like the part number has been like a TSOP, but the board is laid out for SO14.
Now we've been talking about surface mount, and this is the parts that sit on the surface. So that's SMT, surface mount technology, solder, part, oven. Now there's also the other side of the component spectrum. Can you tell us more about that, Mike?
That would be through holes that actually go through the board. And then that goes through a process of you can either hand solder it, or we even have two selective solder machines where they pinpoint to where they need to solder.
There's also like wave solder, right? That's another way to solder these pins. So you have a circuit, parts go through holes, and so the pins stick off the bottom. And then there is like a wave solder that basically generates a wave of solder that touches the circuit on the bottom and end up soldering the pins. Mm-hmm. Or we have the selective solder. So why did we decide to get a selective solder, not a wave solder?
For selective solder, that means you don't need to glue parts at the bottom, or you don't have to have pallets made to shadow or,
I see. So the wave on the bottom, if you have components, surface mount component on the bottom, that wave would just basically melt them off, or the parts need to be glued so they would not fall off.
Correct.
How does that work in selective solder?
So selective solder is just a very smaller nozzle that goes right to the pin. It's like a little mini wave. It's just a little point.
Like for me, it's like a solder fountain. So there's like this little solder fountain. The solder sits in a large pot and it melts, it becomes liquid, and then the one fountain goes up and touches the pin and solder them, or actually it can sometimes just go across, like it zips through a connector. It doesn't need to touch individual ones. Mistakes can be very expensive when you're building circuit boards. So, of course, somebody can accidentally place a part, the wrong part, the wrong orientation of a part. And working with Mike for a very long time, I can speak up for his quality of work and the very few mistakes he has made over the years. But nobody's perfect. We all make mistakes. So what was the largest mistake you've ever made? Was it here at GHI, and what was it?
It was here at GHI. There was a part, it was a BGA, and somehow the packaging information got shifted one pin over, and so the machine was actually placing it one row
but
over. One row over.
The BGA.
And since it was so fine pitch, it was very hard to see it, and the first process of it coming through the machine. And the only way we caught it is when we were to test the board, it didn't work.
Okay, so
and then we had to stop.
So when visual inspection didn't show it, it's so close. It's such a fine pitch. How can our customers make your life easier when somebody come to us and they want you to assemble circuits for them and the team, or our engineers come to you and the team and they want you guys to build circuits for us? How can we and the customers make your life easier?
A complete bill of materials for all the part numbers, including the ending of the part numbers that dictates of what the package is of that part, and making sure that if you have top and bottom or surface mount soldering, to make sure there's fiducial marks on both the top and bottom of the boards.
What is a fiducial?
That is where the machine actually uses it to align the boards in the machine, so that way all the parts are placed exactly where
So it's a mark.
It's a mark.
It's a mark on the circuit, and the machine uses it?
The machine uses it. There's a downward camera that checks it out and makes sure that it aligns the part each time it comes in the machine. It's always realigning that board to that machine.
Yeah, even with that, it's still mind-boggling to me to see how fast the machine goes. And then it's placing like an 0402, a part that you can barely see. And then the machine just picks it up and places it perfectly in spot. It's really amazing. And I have even beyond appreciation to this, because I started this soldering circuits by hand. Like I was hand making circuits. So now to see the machine building circuits for us, it makes me just in awe, happy about what's happening. I want to end this by saying I personally greatly appreciate everybody at GHI Electronics, but especially for somebody like Mike, who's been with us for a very long time. He's family at this point. We've gone through ups and downs and goods and bads, and we have moved through buildings and we've moved through machines, and we have gone through so much. So I really want to say thank you, Mike.
Thank you, Gus. Appreciate it.
And until next week, have fun and keep coding circuits.